solve log 8 to the base of square root of 8 equals 6. So we can change this to 8 equals square root of x to the power of 6, isn't it? So, well, square root of x to the power of 6 is actually x to the power of 6 over 2, right? So, which is x cubed. So, x cubed is 8, hence x must be 2. Cool. Next question, B. A quadratic equation ax squared plus bx plus c equals 0 has solutions of these. Find the values of the integers a, b, and c. Right, so because these are solutions, first of all, we can build this equation. X minus 1 fifth times x plus 2 thirds equals 0, right? However, a, b, and c here must be integers. So when you expand this, you will end up, a is okay, but b and c are fractions. So we could have 5 times 3 here. So times by 15 on both sides. That means 5 times 3 on this, right? So I'm going to do 5 times the first bracket and 3 times second bracket. So 5 times first bracket gives me 5x minus 1 times 3 times second bracket gives me 3x plus 2. So they are the same equation. Now you can just expand this without times by 15 and then at the end times by 15. It's the same, but I find this way is easier. Then expand these two brackets. So 15x squared plus 2x, plus 10x minus 3x minus 2, which is 15x squared plus 7x minus 2 equals 0. And then you just recognize a, b, and c. A equals 15, b equals 7, and c equals negative 2. They all are integers. Sweet. And question C. This is quite an interesting question. First of all, how would you break 75? So 5 times 15 is 75, isn't it? And then 5 times 3 is 15. So that means that 75 is 5 squared times 3. So log 75 to the base of a is actually log, I'm going to write here, log 75 to the base of a equals log 5 squared times 3 to the base of a, isn't it? And then, according to the property of log, I can add them. So, which means log 5 squared to the base of a plus log 3 to the base of a. Okay? And now, as you know, these two, the index comes front. So 2 log 5 to the base of a plus log 3 to the base of a. And log 5 to the base of a is q, isn't it? So that's a 2q plus log 3 to the base of a is a p. So that should be the answer. There was a similar question in scholarship calculus. I think it's last year or the year before. Quite similar. Question D. An expression for the sum of two squares can be written as this. If a and b are solutions of the equation x squared minus mx plus n equals 0, find an expression for a squared plus b squared in terms of m and n. All right. So because a and b are solutions, so like question C, I can write x minus a times x minus b equals 0, right? That's the equation we are looking for. And when I expand, I have x squared minus a plus b x plus ab, isn't it, when you expand that? So comparing with this, right? So a plus b must be m, and ab must be n, isn't it? Right? So what did he say? A squared plus b squared is, a plus b squared. So that means m squared minus 2n should be the answer. So I'm going to write a squared plus b squared equals. All right. That was an easy question. And I think this is the last question, isn't it? So as I said at the beginning, when I, made question one of this algebra exam, this year is way easier than last year. All right, question E. It's a bit challenging question, can be, but yeah, let's see. Shiloh is about to play a golf hole. She starts at point A, as shown in the diagram. Normally, golfers take the route ABC to get to the end of the hole flag. She decided to take a risk and go direct from the start to the end. However, there is a tree in the way that she will need to clear. The start is 2 meters above the ground level. The ball reaches its maximum height of 20 meters when it is 110 meters from the start. The tree is 7.5 meters high and is 200 meters away from the start. Assume the flight of the ball can be modeled by the quadratic equation. Will the golf ball be high enough to clear the tree? All right. So the question is, would the ball hit that tree or higher than tree? So it is safe to do so. So in this question, you have to form that equation, that quadratic equation, right? For this parabola. So you want to do this because it's 2 meters high. So why don't we make this as x-intercept and that as y-intercept? Sorry, it's not an intercept. Y-axis and this is x, right? So we have to simplify the question. So this, like the turning point is not 20 meters high anymore because we pushed 2 meters up. So that is actually 18, right? And the tree, the height of tree is not 7.5, it is 5.5 because you have to take away 2 meters, right? So the question is, once you form that equation, then when you plug that x coordinate, what is the y value? Would that be greater than 5.5? Then it is good. If it's not, it's not good, right? Right. So from that equation, well, we are going to use this turning point, which is 0.18. So according to this, I can say, oh, by the way, there are some more information here. So it says this is 110 meters from the start. So that point there must be minus 110, comma 0, isn't it? So we need that. And that coordinates is, so from here to there is 200. So that must be 90, isn't it? So that point's coordinates at 90, comma 0. We need that. So now, so using this turning point, we can form the equation like this. Y equals k x, oh, sorry. There is no horizontal shift, so we don't need a bracket. So k is a scale factor, kx squared plus 18, right? To find the k, we need that points. So we plug negative 110 into x and 0 into y. So when I do that, 12100. So 12,100 is x squared, right? So minus 110 squared is 12,100, and then k plus 18 equals 0. So Therefore, K value is minus 18 over 12,100. So when I simplify this, I'd like to keep it as a fraction, minus 9 over 6,050. Okay, so that means I can write equation y equals minus 9 over 6,050 x squared plus 18 is that equation. Okay, so now we have to plug 90 to test whether y is greater than 5.5 or not, right? So when I plug, so I'm gonna say y 90. So this means x is 90. So negative 9 over 6,050 times 90 squared plus 18. So I calculated this, and it turns out 5.95 meters. What does that mean? It's safe. She can, take that risk. So I will write the ball is high enough. Yeah, high enough to pass the tree. It's about 0.45 meters higher than the tree. All right, that should be the answer. All right, I will see you with the calculus paper. All right, yeah. See you. Bye.